Today we're going to talk about the definition of a parabola, and I'm just going to ask you to read through all of the information on the first page, but I'm going to talk quickly about the definition right here in the middle. We're going to talk about that piece, okay? So a parabola, as you may recall from geometry, is the locus of all points, or the set of all points equidistant from a particular line known as the directrix and a focus point. Okay, and so that means that if it's equidistant, that the distance from the directrix, and we'll call that, where we can see that's line L here, from that to the parabola is the same as the distance from the parabola to that focus. So each of the lines that you see in this picture are congruent to each other. So this is congruent to that, this one is congruent to this one, and so forth. Okay, so that's the main piece. And then it just goes through and talks about where you see parabolas in them and come up with the analytic equation for a parabola given the definition. Okay, try and take a look at some of those. Okay, as you may recall, a parabola is an even degree polynomial, and it looks like an even degree polynomial. And in finding the definition of a parabola, or from the definition, we're going to find the equation of a parabola. And so we have in example 1 a picture with a parabola, and it has a focus point drawn, the point 0, 2, and it has this line here, which is the directrix, which is the x-axis, as they're telling you. Okay, and again, the definition: parabola is such that xy is equidistant from f, meaning the focus, and the x-axis. So if that's true, that means that this and this are the same length. Okay, well, how do we find length in mathematics? We find it using the distance formula. Okay, so the distance formula, just to kind of review, is x2 minus x1 squared plus y2 minus y1 squared. And you remember that from last year. You did an exploration with Mr. Randall in terms of how it applies, or where it's derived from, the Pythagorean theorem. Okay, so let's let A be any point xy in the parabola. This is our f prime, which is a point on the directrix with the same x-coordinate as A. So if it has the same x-coordinate, that means that we are drawing this down and we're forming a right angle. Okay, so the question is, what is the length of A f prime? So we're looking for the length of this right here. And so the length for that is really just the distance up, which would be length y. Okay, but we could of course confirm that with the distance formula. So if we were to use the distance formula, we'd have x minus x squared plus y minus 0 squared. And so that's the square root of y squared, which just tells us y. Okay, so that's the confirmation that the length of AF prime is equal to y units. Okay, now we're going to use the distance formula again to create an expression that represents the length of AF. So we're going to look to create an expression for that. Okay, so let's go ahead and use our distance formula. So we have the square root of, and we have our 2 points. We have x minus 0, the quantity squared, and then we have y minus 2, the quantity squared. Okay, and so we'll just rewrite that as x squared plus y minus 2, the quantity squared. And we're going to leave it like that for just now, for just a moment. Okay, and now we're going to write an equation that relates the two lengths. So we know that this length and this length are the same. Okay, so then we can go ahead and set them equal to. We can say y is equal to the square root of x squared plus y minus 2, the quantity squared. Now you may wonder, why did we spend some time on radicals in this chapter? Well, we're going to need the stuff we learned about solving radical equations in order to deal with and solve this particular equation. Okay, so we're going to go ahead and solve it for y. And we can see that y is already equal to something, but we have this other y in here, so that's why it's not already solved for y. Okay, so we'll go ahead and square both sides. And as a reminder, when we square a radical, we get the radicand, so what's underneath the radical. So we have x squared plus the quantity y minus 2 squared. And then we're going to go ahead and square this. So you can either use AC box or distribution. And we would end up with y squared minus 4y plus 4. Okay, and then we're going to start to work to solve for y. Now, how do we solve for y? Well, you can see what's going to happen here with these y's. This y, if I were to subtract it over, it's going to cancel with that one. And so then I can start to solve for y. I can start to isolate y or get it by itself. Okay, so I'm going to move this 4y over. And the way that I would move 4y over is by adding it to each side. Okay, and so now on this side, and I'm going to show my work up here, I have 4y is equal to x squared plus 4. And so then I'm almost done. My goal is again to solve for y. So I will divide by 4. And now I have y is equal to 1/4 x squared plus 1. And so that is the equation of this parabola. Okay. Now, since we know that the focus is equal distance from the parabola as it is from the parabola to the directrix, we can kind of look and see here that this would also be the same distance as that, right? So if that's the case, and this is 2 units up from 0, then this whole thing measures 2 units. If this is 2 units, then most likely that's half of 2, or 1. So there's our y-intercept, okay? But we're going to go ahead and confirm that based on the information here. So let's say that we have this point, and we don't know yet if that point really has the coordinates 0, 1, so we'll call it 0, b for now. Okay, so that means that this is b units, and then this is 2 units minus b. Okay, and so if we were to solve that, we know that 2 minus b is equal to b, and so then we would go ahead and add b to both sides. So 2 equals 2b, so b equals 1, which is exactly what we had thought. And then that means we have the coordinates 0, 1, and we could go ahead and check in 0, 1 in our parabola. Okay, so 1 is equal to 1/4, 0 squared plus 1, 1 equals 1, that's true. Okay, so that is the equation of the parabola here. Okay, tomorrow in class we'll also talk about some other options for finding the equation of a parabola given the focus and directrix. Okay. Have a great night.